This is the Pre-Calc Regular Semester 1 review. I'm going to start with problems 1 to 13. Problem number 1 asks you to determine all the symmetries of xy equals negative 5. Now I'm going to do this problem algebraically, although a lot of times, particularly in a multiple choice exam, you can graph this equation and sort of determine the symmetries. If you're going to graph this on your calculator, you need to graph the equation y equals negative 5 over x. So, there are 5 symmetries that we check. The first one is symmetry over the origin. Symmetry over the origin exists if you can replace x and y with negative x and negative y, and you get the same equation you started with. So, is negative x times negative y equal to negative 5 the same as the original equation? Well, negative x times negative y is positive xy, which is still equal to negative 5, so it is. Then, instead of putting a check mark, I'll write yes. The next symmetry we generally try to check is symmetry over the x-axis. Symmetry over the x-axis occurs when you replace y with negative y. If you get the same equation you started with, it's symmetric over the x-axis. So if I do nothing to x, but I replace y with negative y, x times negative y is negative xy. Those two negatives end up canceling and you get xy equals 5, which is not the same equation you started with. Symmetry over the y-axis. You replace x with negative x, but you knew nothing to y. Well, you can kind of see the same thing that happened when you check symmetry over the x-axis should happen again. You're going to get negative x times positive y, which is negative xy, which is not the same equation you started with. Symmetry over the line y equals x. If you can flip-flop x and y in the equation, and it's the same equation you started with, then it's symmetric over the y-axis, or over the line y equals x. Well, when you switch x and y, isn't y times x the same as x times y? It is, because multiplication is commutative. And a lot of times, if you check symmetry over the line y equals x, when you check symmetry over the line y equals negative x, you should get the same answer. Over the line y equals negative x, not only do you flip them, but you change the sign of both of them. Well, if I flip them and change their sign, two negatives make a positive, and y times x is the same as x times y. So it turns out that the only symmetries of xy equals negative 5 are y equals negative x, y equals x, and the origin. Number 2, what is an even function? What is an odd function? An even function is a function that is symmetric over the y-axis. If you check symmetry over the y-axis, you will get it is symmetric, it's an even function. Now, one of the other things I want to remind you is that it's going to be an even function if the biggest exponent of x is even. But not all functions whose biggest exponent of x is even are even functions. But if all the exponents of x in an equation are even, it'll be an even function. Just remember, sometimes you can have an equation like y equals x to the 4th plus 3x to the 3rd. That's not an even function. But y equals x to the 4th plus 3x squared is an even function because both of these are even. An odd function is a function that's symmetric over the origin. In order to be an odd function, the biggest exponent of x must be odd. But not all odd-degreed equations are odd functions. This would not be an odd function because one of the exponents is odd and one is even. But this would be an odd function. If all the exponents of x are odd, it will be an odd function. Just like if all the exponents of x are even, it will be an even function. So it's a nice quick check to determine if something is an even or odd function. If you have an equation that mixes odd and even degrees, it will be neither. Number 3. Describe the transformations on the parent graph of each function. Well, first of all, it kind of helps if you know what the parent function is. We talked about all of our basic parent functions. So for A, your parent function is x squared. The transformation on x squared is right 2. Now, it's great if you can look at that equation and you're like, oh, I know that's to the right 2. But if you're not sure how the new graph moves, if you at least know what the parent function is, graph the parent function and graph the new function, and you'll be able to see on the calculator which direction and how much it went. In part B, the parent function is going to be the square root of x. So the square root of x plus 6 is going to be up 6. Number 4, given f of x is equal to x minus 3 squared plus 7, find f inverse of x and determine whether f inverse of x is a function or not. So the original graph is a quadratic. It's a parabola. And the reason I mention that is because it's going to look something like this. Let's see. The vertex is going to be at 3, 7. It's going to open up, so it's going to look like this. We had something called the horizontal line test. And what the horizontal line test does is if you can draw a horizontal line through the original graph and it hits the graph in more than one location, then its inverse will not be a function. The reason the inverse will not be a function is because the inverse is always symmetric over the line y equals x. So parabolas, its inverse will be a sideways parabola, which by the vertical line test will not be a function. So I can tell you right away that the inverse is not a function. Now let's talk about finding the equation of the inverse. To find the equation of an inverse, you flip x and y. Remember that f of x is the same thing as y, and then you solve this new equation for y. So you use proper algebraic techniques, so you have to subtract 7 first. Then you can square root the other side, and when you do that, you have to put plus or minus in front of it. Anytime you take a square root or a fourth root or a sixth root or an eighth root or any other even root, put a plus or minus sign in front of the radical. And then I'm going to add 3. And traditionally we would write the 3 in front. And then this would be the equation of the inverse. Number 5, graph f of x is equal to the absolute value of x plus 2 and its inverse. So what I would do is I would start, because, this is going to be a multiple choice test, they're not going to ask you to graph it. They're going to ask you to determine which one's the correct graph. So the graph of the square root or absolute value of x plus 2 is the absolute value graph that's been shifted up 2 units. If you're not sure what ordered pairs that graph goes through, just use your calculator. But I'm going to tell you that some of the ordered pairs on it are going to be at -3, 5, -2, 4, -1, 3, 0, 2, 1, 3, 2, 4, and 3, 5. And you could have got that from your calculator. So the graph of its inverse is the graph you get when you flip those ordered pairs. So instead you would graph 5, -3, 4, -2, 3, -1, 2, 0, 3, 1, 4, 2, 5, 3. So 1, 2, 3, 4, 5, -3, 4, -2, 3, -1, 2, 0, 3, 1, 4, 2, 5, 3. And hey, look, that V, its inverse is a sideways V. Number 6 says state whether the graph of f of x is equal to x if x is less than or equal to 1, and 2 of x if x is greater than 1, has an infinite discontinuity, jump discontinuity, point discontinuity, or is continuous. This was called a piecewise function. A piecewise function is one where you have multiple equations being graphed on the same coordinate plane with restrictions on the domain. I'm going to give you a little hint about piecewise functions. The answer has to be either jump discontinuity or it has to be continuous. Equations that have infinite discontinuity have vertical asymptotes. And a point discontinuity is a function that has a hole. So, you can graph this on your calculator. When you plug it into y equals, it must look like this. You put in the equation, and then you use a division sign, and then after the division sign, you put the domain restriction in parentheses. Remember, the inequality symbols are found under second math. That's the test function. Sometimes the domain restriction is a compound inequality, like -2 is less than x is less than or equal to 3. If that's the case, although you can type that into the calculator does not recognize compound inequalities, so you would have to put the restriction -2 less than x and x less than or equal to 3 as your domain restriction. And is also found under the test menu. You would just go to second math and then arrow 1 to the right to logic. Once you type that in, when you graph it, you should see this. A jump discontinuity is when you see a gap in the graph at the same x value. So I want you to notice at x equals 1, they stop at different y values. When that occurs, we call it a jump discontinuity. So the only two things that could have happened is you would see a gap in the graph, in which case it's a jump discontinuity, or the two pieces would connect. And if they connect, it's continuous. Number 7, describe the end behavior of y equals 1 minus x to the third. So first I would graph this in the calculator. The way end behavior works is there's two pieces to the graph. There's the part that's on the right side of the graph and the part that's on the left side of the graph. The right side of the graph is the side where the x values are going to infinity. Now, I realize the graph is going down, but if you continue to find outputs for each of these y values, you'd find them. They'd just be really far down. So, let's get rid of those. As x goes to positive infinity, or in the positive x direction, the y values, since they're going down, we call that negative infinity. The left side of the graph is the side of the graph where x is approaching negative infinity. In other words, it's the negative x side of the graph. Well, if we go in the direction where the x values are negative, the y values are going up, so we say they're going to positive infinity. Now, this is all great that it's drawn on the graph, but this is not how we would write the answer in the multiple choice test. It would probably be written like this. As x goes to infinity, y goes to negative infinity, and then maybe there'd be a colon, and then it would say as x goes to negative infinity, y goes to positive infinity. Number 8, determine the interval or intervals for which y equals -2x cubed minus 3x squared plus 12x is increasing and decreasing. So I graphed this on my calculator, and the other thing was I changed my y minimum to go to -20 because I knew I needed to see down some. So when we determine intervals of increasing and decreasing, we read the graph from left to right, literally from left to right. So as I go from left to right, I am going down because my pencil's going down. So we say we're decreasing. But then somewhere down here, we stop decreasing and we start going up. So we must be increasing. And then we stop increasing and then we go down forever, and so we're decreasing again. Those are the three intervals. Now, we write the intervals as inequalities. Sometimes they can also be written in something called interval notation. It depends on how your Algebra 2 teacher taught it to you, so I'll show both representations. So in order to find out at what x values these intervals are occurring, we're going to need to find this minimum and this maximum. So we can find out at what x value the change between decreasing and increasing occurs. So let's start by finding this minimum using the minimum function. And my calculator tells me that it seems to be occurring at -2, -20. Well, we only care about the x value. So it's decreasing when x is less than -2. And then from x is -2 until this x value, it's increasing. Well, I can tell by looking at the graph that it's 1. And then from 1 on forever, it's decreasing. So this would be the intervals of increasing and decreasing. When I do this using inequalities, the first interval is always x is less than. The last interval is always x is greater than. Any intervals in between the first and last will always be compound inequalities. Now, if you need to write this in interval notation, the first one would be -∞, -2. The second interval would be -2, 1. And the third interval would be 1, ∞. Although sometimes I've seen it written with the brackets instead of the parentheses. Number 9, locate and identify the extrema for the function y equals x cubed minus 6x squared plus 9x. Extrema mean any maximums and minimums. We don't do a lot with point of inflections. We're more concerned with you finding the maximums and minimums using the max and min function on your calculator. So this is what I get when I graph it on my calculator. There's a local maximum and a local minimum, and you can use your maximum and minimum function. This is at a max, and then this is at a min. Although I can kind of just tell by looking at the graph that the maximum is at 1, 4, and the minimum is at 3, 0. But if you use your max and min function on the calculator, you'll get the exact same answer. Warning about the calculator. Sometimes it doesn't like to tell you that that's 0. Sometimes it likes to give you some crazy number like 1.6 e -11, which is what my calculator gave me. Remember that that's scientific notation. That's the same thing as saying 1.6 times 10 to the -11th, which is the same thing as, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm missing zeros here. But you kind of get the picture here. You have to add 10 zeros in front of the number. Well, what is that number? Think about it like money. If I said I'm going to give everybody in the class that much money, how much did I give you? I gave you nothing. That's because the answer really is 0. I don't know why the calculator gives this crazy answer, but it does. It's really just 0. Number 10, it says graph f of x is equal to x over x minus 1, identifying any vertical and or horizontal asymptotes. Well, I realize you can graph this in your calculator, but we're going to review the horizontal and vertical asymptotes. Vertical asymptotes are easy to find. All you have to do is take the denominator, set it equal to 0, and solve for x. There is a vertical line at x equals 1 that this graph will not touch or cross. The horizontal asymptote, I gave you a set of rules for identifying the horizontal asymptote. You can look at the graphing calculator, you can look at the table of values. As a matter of fact, in calculus, you would look at the table of values to determine the horizontal asymptote. But I'm a big fan of doing it this way. There's a rule that says, if the greatest exponent of x and the numerator and denominator are the same, then the horizontal asymptote is the ratio of the coefficients of those terms. Well, biggest exponent of x in the numerator is x to the first. Biggest exponent of x in the denominator is x to the first. The coefficients in front of both of those x's is 1. So the horizontal asymptote must be 1. And that means the graph must look like this. Now on the final exam, we're not so worried about the graphs. There might be a problem that says identify which graph is the right one, but we are going to ask you questions about identifying horizontal and vertical asymptotes of a rational function. Number 11. If y varies inversely with x and y equals 2 and x equals 25, find x when y equals negative 40. We have an algebraic way of doing this. I'm going to do it that way. Some of you can reason this out, and that's fine with me. The key word here is inversely, and the equation for inverse variation was y equals k over x. So if you know that y is 2 when x is 25, you can solve that for k, called the constant of proportionality. It's just a proportion. K is 50. So the equation is y equals 50 over x. So now that you know that y is 50 over x, then you can find x when y is negative 40. So negative 40 is equal to 50 over x. Again, remember, that's just a proportion. So negative 40x is equal to 50. So x is equal to 50 over negative 40. Those zeros cancel. It's negative 5/4. Number 12. If y varies jointly as the cube of x and the square of z, and y is equal to negative 9 when x is equal to negative 3 and z is equal to 2, find y when x is negative 4 and z is negative 3. So let's start with the fact that it says y varies jointly. That means that the input, there's more than one input. One of them is the cube of x, and one of them is the square of z. Those exponents need to remain throughout the problem. One of the most common mistakes I see students make with this is they start with the exponents to find the constant of proportionality, and then at the end of the problem, when they go to solve, they just drop them. All right, so let's start with the fact that y is negative 9 when x is negative 3 and z is 2. So the first thing we're going to do is we're going to multiply those, and I'm going to get negative 108. And then I'm going to divide by negative 108. Well, those two negatives become a positive, and it reduces to 1/12. So now I have the equation y is equal to 1/12 x cubed z squared. Now I can find y when x is negative 4 and z is negative 3. And I just pop that into my calculator, and it spits out negative 48. Last problem I'm going to do on this video, this is from chapter 11. Number 13, simplify each expression. So to simplify 27/8 to the 1/3, we're going to use our properties of exponents. We have a property of exponents that says that you can distribute the 1/3 power to each of the items inside the parentheses. So if you do 27 to the 1/3 in your calculator, it'll spit out 3. And then to simplify a to the 6 to the 1/3, the properties of exponents tell you to multiply those. 6 times 1/3 is 2. There's another way of doing this. You could have rewritten 27 as a prime base raised to a power. Well, the prime base is 3 cubed, and then you could have gone about the distributing and you would have gotten the same answer. Part B, the 6th root of 8x to the 12th. Well, how you write this answer kind of depends on what they ask you or what the multiple choice answers look like. And since I'm not looking at the multiple choice test right now, I'm not sure which type of answer they want you to give. So I'm going to show both formats. If they want you to write this with rational exponents, then what I would do is I would start by rewriting 8 as a prime base raised to a power. And then the 6th root is the same as the 1/6 power. And then I would distribute the 1/6 power. The property of exponents tell you to multiply those, so I would get 3 times 1/6 is 1/2, so 2 to the 1/2, and x to the second. However, if they instead ask you to rewrite it as a radical, don't worry about this problem will be in the next section. If they want you to rewrite it as a radical, or a reduced radical, I should say, reduced radical, then the way you would have done it is you would have broken down 8 into 3 2s, and then you would have written 6, 5, 6, 7, 8, 9, 10, 11, 12. You would have had 12 x's, and a sixth root is groups of 6. Well, you would have found out you could take out 2 groups of x's, but you can't take out any 2's because you don't have enough 2's, and this would be the answer. So if it says rewrite it with rational exponents, this is the answer. And if the problem asks you to do it as a reduced radical, this would be the answer. And that is problems 1 to 13 of the Semester 1 review.